Uh, hey, you're here. The president is here. Well, no one, see, the people on the video think the president is really here, but I'm not going to mention your name. You're over there, young man. Mr. Obama, you sit right there, okay? Anyway, we're talking about systems of equations. System of equations. Oh! Wait a minute. I got a new handle for my pencil sharpener. I have to remember to. A system of equations is when you have two or more equations, okay? And there's lots and lots of applications of systems of equations. They're used for figuring out where two lines intersect, but on a bigger scale, they're used to solve all kinds of mathematical problems, like in space, like if you want to figure out when a rocket's going to hit an asteroid or something like that, you can figure out by two different equations could model it. You can see where they intersect or something like that. But we'll start simple, okay? And we'll start with linear equations, which is what we've been working on, which make lines, and linear equations in two variables. So the first one talks about a grocery store is having an after Halloween sale. So I stole this from the previous teacher, and this happened after Halloween last year, so sorry about that. I know you're all, Halloween didn't happen this weekend, so don't be depressed, you know. This hasn't happened yet. All right. So grocery store is having a sale, and an after Halloween sale on pumpkins. Small pumpkins are on sale for $2, and large pumpkins are on sale for $3. I bought 10 pumpkins for $24 before tax. How many of each pumpkins did I buy? Okay, so I'm just kind of set this up for you. So what you need to do when you have a system of equations, you need to usually come up with two equations, okay? And you have to kind of decipher those equations from the problem, okay? So you got small pumpkins are on sale for $2, and you have large pumpkins on sale for $3. So what I'm going to say, I'm going to call S the number of small pumpkins and L the number of large pumpkins. So what do you know about S plus L? How many do I have altogether? 10. Okay? And then, so that's one equation. Then you have another equation. In this case, that equation involves the price. So the small ones are on sale for $2, large ones are on sale for $3. And then she spent $24. Can anyone give me another equation that would involve those numbers? Amanda?
Would it be 2x plus 3y equals 24?
Yeah, except I'm going to call it 2s plus 3l. Instead of calling it 2s plus 3, because I want to keep the variables the same. Very nice. Okay? Good job. And now we're going to solve these graphically. We're not going to solve, we'll solve them algebraically in the next couple days and give you a bunch of different techniques. But right now we're going to just solve them graphically. And the way that I'm going to do that, I'm going to look at this graph. And so I'm going to put S here and L here, and I'm going to look at this equation. When S is 0, what's L? I'll put S over here and L over here. It doesn't really matter in this case because it's kind of your choice. But when S is 0, L is 10. When L is 0, what's S? 10. So I have one equation that has these 2 points, 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to connect those with a line segment, okay? You don't need a whole line. Anyone know why I don't need a whole line? I don't need to keep going. How come I only need to go just from here to here? Do I have any negative? Could I have negative numbers here? No, because you can't have, because S and L are the number of pumpkins, and I can't have a negative number of pumpkins. Okay? Now I'm going to do the same thing for this little equation here. SL. When S is 0 in this case, what's L? Look at this problem. When S is 0, what's L? Huh? 3 times what number gives you 24? 8. Right? When L is 0, what's S? 12. Okay? So now I have two more numbers. I have 12, 0, and I have 0, 8, which is over here. And I'm going to connect those two with a line, segment, okay? And where they intersect, that's my solution, okay? And so this point, what's the coordinates of that point? What's the coordinate of that point? Is it 6? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, right? 6, comma 4. And so, how many of each size pumpkins did I buy? Apparently I bought 6 small ones, yes, and 4 large ones. Let's see if that worked. 2 times 6 is 12. 3 times 4 is also 12. Does that make 24? Is 6 plus 4 10? Yeah, so it works in both equations. And then you answer the question, I bought 6 small pumpkins and 4 large pumpkins. Now you're all set and ready for the pumpkins on sale. I saw a bunch of smashed pumpkins on the road this morning, or yesterday already. You guys don't go around smashing pumpkins, do you? Huh? Isn't there a band called the Smashing Pumpkins? Yes? I've heard of that. Okay, so that's that one. Questions? Okay then. So now we're going to continue to fill out this worksheet that says blank, blank. Oh, 6, 4. 6, 4 is a solution to the equation S plus L equals 10. And 6, 4 is also a solution to the equation 2s plus 3l, 2s plus 3l equals 24. When you solve more than one equation at the same time, it's called solving a system of equations. I can't spell. Let me try that again. Equations. I'm not up either yet. Okay? Finding the point of intersection, okay, is one way to solve a system. Now, probably this one is more accurate to solve, because if we don't make our graphs accurate, it's going to be hard to tell exactly what your solution is. But in some cases, like if you have really but different types of equations, not linear equations, sometimes it's impossible to solve it algebraically, so the only way to solve them is graphically, like with the graphing calculator or something like that, and approximate the point of intersection. Okay? Okay, got that down? Can I move on, Ellie? All right then. Okay, we're moving on. Without graphing, how can you determine whether the point 2, 3 is a point of intersection for the following lines? Who could tell me that? Jessica. Right. Yep. In both equations. Okay. So you would have to plug in 2 and 3 into both equations. So 2 times 3. That's wrong. Okay. 2 times 2 minus 3. Does that equal 1? Is that true? Yes. So that one checks. 5 times 2 minus 3 times 3. Does that equal 1? 5 times 2 is 10, minus 3 times 3 is 9, and 10 minus 9 is 1, so that's checked. So is 2, 3 a solution to this system of equations? Yeah. Guys, so one way to check, like we did with the first problem on your test, you have to take the point, plug it in, and see if it makes it true. Okay? Ready to move on? We're cruising now. Okay. So, without, oh, that's not it. Where's the next side, next page? Here we go. Solve the systems graphically. Okay. So in all cases, like in this one right here, it might not be best. No, it works. But it might not be best to do the technique that I just used because, like, if I plug in 0, I get 5, y is 5. But if I plug in 0 for y, I get out 5/3, I think. And that's not very accurate. So it might be easier to put this into slope-intercept form. Who could tell me how I put this into slope-intercept form? What is this in slope-intercept form? Y, come on. Jacob A.
Y equals -3x.
Right, y equals -3x plus 5. This might be a better form to graph this in because now I know the slope and I know the y-intercept and I'm not going to be inaccurate. So I'm going to go up 5, 1, 2, 3, 4, 5. And then a slope of -3 means I go down 3 and over 1. And then I could graph my line relatively accurately. I'll try to anyway. That looks pretty good for a rookie. I'm not a rookie. I'm a seasoned pro. All right. So there's this line that I just graphed. Okay? And this line, x minus 2y equals 4. If it's in this form and both things are divisible by 4, it's probably easier to just graph this one by plugging in 0 for x. When x is 0, what's y? -2. When y is 0, what's x? When y is 0, what's x? 4. Right? So with this line, I could just use the intercept method, which is what I just did. 0, -2, and 1, 2, 3, 4, 0. And then I'm going to draw a line through those things. And you got to be kind of accurate. What's the slope of that? I don't know exactly, but I'm going to guess that that one's going, am I on it? Pretty close. And what you're looking for is a point of intersection, which appears to be right there. What's that point? 2, -1. Now, to make sure I get it right, how can I make sure I get it right? Plug in the numbers and make sure they work. Okay? So I'm going to go 3 times, so I'm going to plug into this equation first. So 3 times 2 plus -1. Does that equal 5? Does that check out? Yes. Okay. And then I'm going to go 2 minus 2 times -1, right? Kind of like that. And I want to know if that's equal to 4. Is that equal to 4? Yeah, because that's 2 minus -2. It makes 4. So that checks as well. So my solution is 2, -1. Now the important thing to know with this is that they don't always cross at nice even points like that, right? So that's why we have to have another technique like algebraically. In this case, I was lucky. I graphed my graph pretty accurately and I found the point correctly. But if it crossed at like 4, 6 2/3, it would be really hard to figure out what exactly that point is, right? So in this case, graphically works, but it's not as accurate as solving it algebraically. Okay, a couple more things. So without graphing, here, let's take a picture of this. Make it bigger. Place capture new page. Without graphing, how many solutions would each one of these have? So can anyone tell me how many solutions that one would have? Jessica can. How many?
1,
Well, what about the slopes, though? What about the slopes of those two lines? They're the same. So these two lines are never going to cross because they both have a slope of 4 and they have different y-intercepts. So these lines are never going to cross. So if they have the same slopes, you call it, there's no solution. Okay? What do they call that? There's a big word for it. No solution, parallel lines. Parallel lines. Parallel lines. There's a word. I'm looking for the word. I think it's called indeterminate. It's called inconsistent. Inconsistent. To inconsistent. Okay? With these ones, so you're not actually finding the solution. You're just kind of doing it. How about this one? What would the slope of this, well, if I turn this into y equals mx plus b form, I'm going to come down here, okay? I'm going to divide everything by 3. When I divide everything by 3, so I have 3y equals 6x plus 9. I'm going to divide everything by 3, divide everything by 3, divide everything by 3. I get y equals 2x plus 3. What do you notice about this line and this line? Same line, okay? And so what that means, same line, okay? That in disguise, sometimes they're like disguising this line as this line. That means you have infinite solutions. So those two lines are on top of each other, okay? And the last thing that could happen, so either they're parallel or they're the same line. Are these lines parallel? No, right? So with these lines, they're going to cross. So if they don't have the same slope, they're going to cross at some point. So this one, right, it has 1/2 plus 9. This one's 5x minus 12. So it's going to be going something like this. Somewhere, those two are going to cross. So different slopes, different, I can spell, different slopes. Those are said to be different lines, different slopes. Those are called independent. Independent. And one solution. One solution. And apparently this is called dependent. Dependent. Dependent, infinite solutions, independent, one solution, solution, parallel lines, inconsistent. Okay? So when you're looking at equations and you're trying to tell whether they're parallel or the same line, just look at the slopes. Last thing. Yay. Okay, so the last thing is just trying to put these, let's just try to write, maybe you guys could try, okay? Let's try number 1, or letter A. See if you guys could come up with an equation, okay, involving the 31 people going on a ski trip with 5 vehicles. A van can seat 7 people and a car can seat 5 people. How many vans and how many cars will be needed if there's no empty seats? You could talk to the person next to you and try to figure it out. See if you guys could work together. I have to unpause. Unpause. That's what happens if I have time. Okay. And but I have to collect them back because there's a few people that have not taken them yet. And Nick, you need to come and finish yours, right? When are you going to do that? Okay. Okay. This is old. Where are you going? No, you're not going. Just stay, please. Come on. You got what? 10 minutes? We got 9 minutes left. Hannah Gross. This is old stuff. Who wants to walk around and pass back some old papers? Come on in. Here you go. How many pass back to me? You want to do that, Nick? I'll give you a value for participation. Value of a bonus point. Here you go, Allie. Mr. Cole Conley, here's an old quiz. Cole doesn't sit there anymore. Where does Cole sit now? If you did, I think we made a mistake there. You did okay on this last test, so you still need to take the chapter 1 test, okay? And then you'll be not totally caught up, but you'll have some, grade will be a lot better, because that's not the notes. All right, I didn't even grade that, because you already took it, and you did okay on that one. We made a mistake in making you retake that. I meant to give you chapter 1. Okay, so who wants to pass out some papers? There you go, Deanna. Who's passing out papers? Nick, Deanna, and Allie. Who else wants to pass out some papers? I'll give you $1. There you go. Thank you. I'll give you a paper. No, I didn't want to give you $1. Okay. Okay, Ian's passing out some paper. I got it. And here comes your test. Okay? Jacob B. Were you here to take the test? I forgot to get your name on. I figured that was Charlie Banks, that's you. Claire Muckle, that's you. Andy Castro, that's you. Jacob Albrecht. You know what? Just keep the test. I'm going to make a Form 3, okay? For people want to take it and people need to make it up, okay? Wait, Nick hasn't taken it yet. Never mind, I need to collect it back, but I do want you to see your tests. Where's JK? What? The Math Excel work I just recorded in my book. If you did it, I give you 5 points. I haven't put that in yet, okay? So don't worry about that. You got credit for it. Mr. Cole, Mr. Tate, Hayden Reader, Sophie Schuler, Quinn. Where's Quinn? Quinn. There you go. Jessica. Jessica got everything right. I gave you 1 point for putting your recent accomplishment on it. You pass this down to Aline, you sir. Kurt. There you go. Gia DeWitt. Pass that down to Gia. Meadow Martin. Where's Meadow Martin? My favorite Martin. David Waite. Getting the synchro duet. Andres. All right. Katira. Whoops. I put your recent accomplishment for you, Katira. You forgot to do it. Haley, there's your test. Chase, where's Chase? Can you give that to me? There's no name on this. There's no name on this. I don't know. Chase S. Where's Chase S? Over here. Where's Akash? Where's Will Ponder? Where's Ellie Redburn? Ellie Redburn, you're over there. Where's Caleb Michael? Okay. Where's Ian K? I'm right here. Okay. What did he say? Okay. I'm just going to throw this away. I don't know what this is. Your test? Jacob A. Jacob Bernstein Center. Thank you. Remind me to give you points. Let me look, Jake. Period 1 out. Wait. I know we got a grade on it. Where did it go? Jacob A. Oh, no.
There's somebody.
Is that Jacob A's? So on your test, I added up all the points. I added up all your points. There were 54 total points, but I gave you 1 bonus point for putting your thing you're proud of. So actually, So if you got like a 40 out of 54, I count it as a 41 out of 54. And then I divided whatever that number is by 54. And that's how I got your percent. Okay? Why don't you look at that? Just keep them, I don't care. I'll give Nick a different test. Or Nick won't cheat. I'll give him the same test. You don't cheat, right, Nick? Okay. So keep your test if you got a bad grade. So you say you got 75 or lower and you want to get a better grade. Listen up. Shh. Listen up. If you got 75 or below, you want to get a better grade. You make the corrections on a separate sheet of paper, okay? And then you come to take a retest, okay? So you could come and get help with me, okay? Or make the corrections on your own if you have someone who can help you, okay? And then you can take a retest within the next couple of weeks, okay? By a week from next Friday. So 2 Fridays from now, that's your time cut up. Is that fair? Is that fair? Is that fair? You don't get to take a retest. You have to do it right the first time. You'll be okay, right? Okay then. Is that good? We're all good? All right. Well, with that said, let me tell a couple more jokes. No! Why do they give sick in... These are so bad. Never mind. The jokes, you just think they were dumb. My jokes are much better. Okay. Do you have any questions about your tests? Do you have any questions about life in general? What? Oh, I forgot to give you your bonus. I did put bonus points in there. I put that thing where you, the little extra credit puzzle. I did your pretty pictures you drew. Those don't count much. They're in the homework category. Who just helped me hand out papers? Hannah, Rose. Ian, you helped me, right?
Yeah.
Who else helped me pass out papers? Nick did. And Allie did. No, that's all that is. So, okay, so some of you need to work a little bit to pass the class, okay? That means making corrections on your tests and coming in and getting some help, okay? Taking a retest, all right? So, and the best I'm going to give you if you take a retest is 80%, okay? That's the best you can do. Because that's not fair to the people who studied hard the first time. So if you got 75 or less, you can do corrections and take a retest. Okay, have a nice day. Don't play in traffic. And some of you can play in traffic. Quinn can play in traffic. Okay? Okay? Not great, but I had a bunch of low scores and they had some high scores and some low scores. Yes, ma'am.
Okay, so I did this.
Oh, okay.
And I was, the day we were told about the mathematics, I was gone, so that's just the word.
Okay. Here, I haven't put that in. So just take that. Take out. Yes, sir. What is it?
Do I get a credit?
Yeah.
If I like on the year something?
Yeah, you'll have to email it to me because I don't have time to put it in. No, yeah, because I won't remember to put it, because then I have to go to the campus. Tell me tomorrow, try to tell me tomorrow, okay? Okay? Good. Sounds good. Hello, good morning. Jacob Burns, who's up to This is one out. I don't know what this is. I'm gonna throw that away. I'm gonna stop this. I'm gonna stop this. Yes.
Mr. Leader, what's the magic cell about?
You started it.
What?
What do we have to do for the magic cell?
There's like 3 problems. You have to look. Hi. Do you have, how many of my books do you have right now?
I think one.
Okay. Are you going to give it back?
Maybe.
You're gonna-
That's some.
There's one missing on my desk.
I'll bring it tomorrow.
Okay. And I gotta stop my recording. Uh-oh. My mouse froze.
I missed to do this. So I missed to do a class on Friday, but I was able to watch the video online.
Huh?
Just need a few questions though.
Okay, I'm gonna go over a few things. It's okay. Oh, it's still going.